Are you guys ready to
So you'll
start?
have plenty. Yes.
We are at 10:01. Let's do this. All right, we're starting the
The
broadcast.
broadcast is now starting. All attendees are in listen-only mode.
Hey guys, good morning, good afternoon, good evening, wherever you are in the world. Hello again. I'm Mike Aubry, along with my two compatriots here, Princess Aliyah and Chuck Alexander with Solid Concepts. Hope everyone's doing great today. What we have in store today, there's 7, 8 of you on the webcast right now. We anticipate we'll have a couple more, but we think this is going to be actually a more intimate uh, broadcast. So the three of us, we were talking before we started, and we wanted to actually start off this webinar by getting to know you. So kind of reach out to you guys and have a conversation, because we're curious to hear what you've been doing, just in terms of the general competition, and then also in the realm of what we've been doing in these last couple webcasts about talking about how is the designing going, how's your modeling going, and then from that, what do you guys think in the 3D print? That way we can get some kind of some real-time feedback from you, and we can adjust the conversation. So yeah, before we jump into that though, I wanted to give the forum over to Princess Aliyah with just kind of the general announcements of what's going on with the challenge. So Princess Aliyah,
Well,
hello.
thanks, Mike. Great to see you and Chuck again. And hopefully one of these days we'll be able to do a webcast where we can get rest of our team members on as well.
Absolutely.
That would be kind of nice. So maybe when we're doing our interactive webinar today, perhaps whoever is talking, we can bring them on as one of the
Totally.
presenters or panelists. That's your job. I know
I can do
you'll
it.
take care of that.
I can do that.
Okay.
Yeah. Yeah. As long as
I want to.
yeah, go ahead. Go
Uh-huh.
ahead. Yeah.
Sorry.
No. I was
Okay.
just gonna say, as long as you guys, those of you guys viewing right here, if you got basically a microphone set up, or if you even have a webcam, we can definitely set it up so we can have a more kind of one-on-one, face-to-face interaction here. It doesn't have to be all through chat, but we're available on chat too.
All right, cool. All right, I'm going to try to make a couple of announcements and then the floor is yours. Number one of the things that we're changing, actually, first I'd like to say thank you for submitting your design concepts. It seems like some of them might not have come through because we had several teams submitting at the same time. So if you have not gotten a response, that this is a confirmation that your design concept has been submitted, please resubmit your design concept. The TACP is working on feedback right now, and we'll be getting feedback to the teams as they start finishing whichever team they're working on, and then we can do a back and forth as well. If you have any questions, go ahead and send an email back and say, okay, I don't really understand this feedback. What do you really mean by it? So we'll make sure to clarify that as well. Second, one of the other things we're going to start doing is monthly webinar, which would include our team members for WCU ABC, as well as the leadership team and perhaps some of the TACP network advisors as well. What we want to do through that is we want to actually be able to interact with you guys, get feedback from you on the overall process of the actual WCU ABC and how we can improve and facilitate and help you achieve your goals for your UAV. And in the long run, how can we work together to actually stop the poaching? Because that's really the main focus of the challenge, is to create a vehicle or a fleet of drones that would be used for counter-poaching purposes, because we do understand there's no one type of vehicle that will work for this particular mission. We'll need at least 3 different types perhaps. So we're hoping that teams will have some really good ideas besides the regular short endurance, long endurance, or a blimp. Some other creative ideas. We're always open for hearing from you as well. So monthly team meetings. So the first one we're going to be hosting would be on Sunday, March 9th. I'm going to test a weekend day because it seems like teams get together on the weekend and they're able to meet. So possibly that could become a better day for our monthly team meetings. If not, we'll be willing to change it and set it up for a different day or time. So that's 2. Number 3, which is one of the really, really big, important announcements, is we are working towards our fact-finding mission 2, which means we're working on the back end with the Kruger Dream Team, and it just so happens Mike is part of our Kruger Dream Team, and so is Chuck from SolidWorks, and several people from
Solid
TACP.
Concepts.
Solid Concepts, I'm sorry. sorry about that, Chuck. But we have a fantastic team together that are helping us customize Asia drone Cyclops C. I believe that's the one we're working on, or one of those platforms that we'll use for our fact-finding mission too. But we're also working to take Skate back into the park, and this would be a 2-month mission that we're going to be doing with the rangers, with the operations of Kruger National Park. So hopefully that'll help us collect enough data that we can actually integrate into the algorithm that Dr. Tom Snitch is creating, which focuses on areas of high risk and also provide the teams the data they need in terms of recognition of rhinos and the other animals that will be available in the park. So we have, that's part of our goal, but the other goal is to really disrupt the poaching. So we want to be able to get in and show that this can really make a difference. Obviously, this would not be the actual aircraft flying, but it could be possible that it will become part of the fleet of drones that would be flying in Kruger and other parks around the world. So that's our big announcement, that we'll be launching that starting sometime in April. We don't have exact dates as of right now, but I figured that you guys would be thrilled to hear there will be a fact-finding mission too that will have a lot more details for requirements as well. So that, I think, should cover it on my end, besides the fact that we do have other webinars on the makerspace movement. I have some webinars coming up with the pilots of Kruger National Park that went with us from Aurora Flight Sciences, and we're hosting a webinar through them to kind of talk about their experience as pilots in Kruger, and that's scheduled for the 3rd of April. We will have a link and registration signed up shortly within the next week or so, so stay tuned. Make sure you participate on the monthly WCU ABC leadership as well as team meeting, and that's scheduled for this Sunday at 2 p.m. and our registration link will be sent to all the teams by tomorrow evening. Okay. All right, Mike, thank you very much, and the rest is up
That's
to
awesome.
you guys to take from here.
Thank you, Princess Aliyah. That's so, yeah, we'll look forward to that on the updates for that. That's awesome to get that regular cadence going. I think that'll be a really good thing for, I know our team is, we have questions and stuff, so we'll definitely take advantage of that. So the final question here for kind of Chuck and I, would you guys, and actually just go ahead and just write me write us in the chat as opposed to just waiting on me to do the poll. Would you guys like us to do more general training like we did last time, or do you want to do more advanced stuff? And then if you had specific examples about what you're working on, quick throw that stuff down there. And then we might, like Jay, actually, if you're, you've written a couple questions here. If you're fine, actually, I would like to actually unmute your microphone. So if you have a microphone, let me know. I'd love to actually quick ask you a couple questions here. With this one, guys, I guess we'd like this webinar to be more conversational and ad hoc. So we're gonna have more one-on-one interaction. Jay does not have a mic. Okay, no worries. I'll just keep talking with you over the chat. Alex would like to see more complicated examples. Okay, we can definitely go down there. Alex, do you have a specific one you're looking at? The ones that we have, and I'm going to make Chuck model all the complex ones, by the way. We've been playing around within my group, being able to 3D print a tail. So basically the back end of where the fuselage and the tail would come together, we're playing around with that. We can show off that. I can show off some of the ways we're creating some of the sparring within the model. Brad's got a question around, can we show the honeycombing process that Chuck uses to lighten parts? Yeah, Chuck, if you feel comfortable with that, we can go down that route too. I think that's... Brad's on my team, so selfishly, I think if you're good to talk about that, I'd love him to get that information. And then, so yeah, let me know what you guys are looking for here. So a couple of things. Elmar has a question around... Elmar was saying that he tried to install the update and then GoToWebinar got mad at him, so I feel your pain, man. It's a good update, I promise. Okay. Okay.
Mike?
Yes, ma'am. Hello?
Can you make me an organizer?
I
Yeah,
can.
so-
Oh,
sorry,
I'm sorry. I
can
thought I
organize
did.
it?
Let me, yeah.
Yeah,
Let me go.
I thought I told you not to, but now I realize actually I think I do need to be an organizer.
Yeah,
so
here.
let's see
You
the
can see
questions.
you can see these chats as they're coming in as well. Okay, so let's go down that line. So I was seeing requests around seeing some, how would we approach modeling some stuff in Fusion and complementing. A couple of you guys have said that you're already using some existing conventional CAD. So I would like to, I guess, first off, talk about some of the differences between what kind of Fusion's able to get you, along with complementing what you're doing in your existing CAD systems. And then how about that? Then Chuck, if you want to talk about some of the honeycombing stuff,
Sure.
let's do that. And then we'll move on from there from some of the tangible examples that I have of where we've been successful kind of using Fusion. And then from there, we'll kind of see what questions come in there. I'm seeing a couple people with questions with some kind of more fundamental questions about interacting with Fusion. So if we need to go back that direction, we can. Does that sound like a good plan, guys? Silence,
Sure.
silence is ascension. So we'll move on with that. So I'm going to share my my screen here, and then the first question is kind of how can Fusion help complement stuff what you guys are doing with your 3D modeling today from other systems? So let's tackle that question head on. So let me know when you guys can see my screen. I'm sharing my webcam, so I'm going to share my screen. Let's get this. So you guys should be looking at, and then Brad, don't have a heart attack. I was going to show off some of the stuff that we're working on, actually with some of our latest concept. I don't feel too bad about this because one of my teams, the Oxpeckers, our big charter is being open source. So we're trying to be as transparent as we can in our design. But I wanted to, Brad, if you hate me, you can send me some hate mail in the chats. Can you guys see my screen? Chuck, can you see my screen?
Yes, I can.
Okay, brilliant. So, guys, let's talk about kind of where Fusion is in the hierarchy of like computer-aided design systems. So I know that a lot of you guys are using systems like called Pro Engineer, SolidWorks, CATIA. For those of you who are new to CAD, these are what are called parametric modeling tools. And so what we mean by parametric is if you create a design, you can build up geometric relationships between the different parameters. So like, for instance, if you have a certain width of something, or if you have a certain length that you might anticipate changing later, it's very common to use a parametric modeling tool to help you to be more adaptable as your design moves forward. So one of the big things we talk about, like how is Fusion different from that? Actually, we begin by talking about is actually there's a lot of things within Fusion that make it very similar to that style of modeling. In addition to the parametric style of modeling, Fusion offers with it several other ways of modeling. So we offer ways of being able to model without having to model equations or set up parameters. So we call that direct modeling. And we also offer what we call sculpting, which is the ability to be totally free of even having to confine yourselves to your conventional geometric shapes. You actually can describe things more on a point node molding basis. So the first thing, and how is Fusion different from conventional modeling tools, is it's got a lot of flexible ways to go about creating the same geometry. So let me show you kind of what we mean and how we're the same between things you guys would have seen within SolidWorks or Pro Engineer or CATIA. To give you a little background about myself, I'm a mechanical engineer by background, and I've been involved with CAD for probably 10 years. So I've worked for a computer simulation company that was using basically all those different tools mentioned. So I'm pretty well versed on kind of that side of the universe of design. So let me tell you about some of the things that kind of how stuff that you're going to find familiar in this environment. And then we'll talk about some of the differences, and then I'll show you some of the areas that you can kind of take advantage of both and why people use both in tandem. So what we have here within Fusion here, this is the 2D modeling environment. So for those of you guys that are using those tools we talked about, this will be very familiar. I mean, so we can go and add things like, your dimensions, go from there. So yeah, if I'm just setting up my dimensions here, you can see that the little yellow things are locked, saying that those are now locked dimensions. And then if I return it down there, we now have a tangible object. And so you can go and you can continue making things, and you can set up relationships with these things. So this would be like an angle along with the length, 82 or 85 or whatever. You can do all these types of different just common CAD functions within the 2D modeling environment. So actually here, if we were just going to set up something like maybe like the beginnings of a fuselage for a drone, this might be what it looks like. So we have your sketching environment, all of your various things you'd expect to see, like your rectangles, circles, whatever. So along with that, along with your dimensioning, so we can still pull out these dimensions. You can build up. So with these guys, actually, let's add this thing first. It likes the order. As you build up these dimensions, so like for instance, this guy, you can go back and change them later. That's what we call by parametrics. You can start building up how these things interact. You can also build up relationships between the dimensions. So this guy, if I always want maybe this dimension to be proportional to this dimension. Actually, if I click and hold down on this guy, if I just kind of double click on him, actually double clicking, you can see that it's actually called D2. That's the name of it. So D2, if I always want this guy to be proportional to that, actually I can call out D2 and then multiply it by, like, if I always want it to be twice the length of that guy, you can actually build up that relationship, and so if I update one, the next thing will update. So for those of you guys that are using all those tools, it's like, well, that big whoop, I can do that everywhere. Well, so this you should be feeling very familiar with kind of how these things are built out. So that's kind of the sketching environment. So for you guys that are in that world, so we still have things like constraints, we still have parameters, we have parametrics. I mean, this is one of the things we just rolled out. So if I go and I take this guy, and then I can make like a revolve or something, you can see that hey, that kind of the conventional ways of modeling in that side of the world, profile, axis, those are all available to you. Now let's talk about some of the ways that we're a little bit different. So some of the ways that we're different is we're trying to make it so that you can model with building these equations and relationships together, but still have it so you are highly adaptable and not as constrained by them. So one of the ways we're trying to make it so that people aren't constrained is trying to make it so it's just a lot easier to see what you have actually been modeling. So to show you kind of what this interface looks like, in your conventional tools like your SolidWorks, whatever, you have your parts, and then usually within that they talk about what the features are that are underneath it. What you see we have down here is actually Fusion has taken on more of a narrative style to how modeling is approached with what's called the timeline. So you can see down here I'm able to actually, regardless of the body or part, or if this is a full assembly, we actually can see left to right a narrative of how we're creating our part. So CAD becomes really more of a conversation than rather just a series of parts that are intertwined together. So actually I can quite literally, I can pull this guy back and you can hit play if you want to describe how did you get there. Like, so imagine that you're working with different teammates on a model and saying, well, gee, how did you actually model that? Rather than having them try and figure out between your feature tree all the thousands of different equations that you're pulling together, and then trust that maybe somebody was smart enough to go into the parameters and actually make sure they gave the correct names to them so you know kind of which ones will update and which ones won't. With this sort of style of modeling, they can actually kind of help themselves and better understand the way you went and created it. And so this makes it so that it's easier to update things later on. It's a very exciting tool. This is one of the first, we are the first parametric modeling tool to have this type of approach in our CAD modeling system. So what's one of those key differences? I would say it's not so much that we're moving away from old ways of doing parametric modeling. It's just that we're trying to open up the ways to make it more flexible to you. Let me make sure I'm kidding. So any questions here? Okay, so we have a couple questions that have come in along the lines of people trying to program things into CAD, and then there's a question about how can we use other CAD data. So let me jump into those questions. Okay, so next thing of kind of how are we different from existing CAD tools? I just showed you some of the ways that we're able to do parametric modeling. So if you want to approach, can we model stuff in parametrics? You can. What I've found among a lot of people that have a robust parametric modeling background, a good example would be my teammate Brad, who's on this call. He's a great SolidWorks user. What I've advised with him is like, well, the stuff that you model well with in SolidWorks and you have access to it, use it. But take into account the stuff where it's you can't get it done, or it's just going to be a pain in the rear to update things. So, for instance, if maybe the way it was modeled didn't have the right set of parameters to update it later, well, then all of a sudden parametric modeling becomes a little bit difficult. So it's a question then of, gee, how do we adapt existing geometry to suit our needs? And let me show you kind of what Fusion does in this case. So in this case, if I was like now saying I don't have any reason left to use this parametric modeling setup, or if it's coming from SolidWorks or Pro or something, you actually have the ability to turn off your design history, turn off parametrics. I know, crazy idea, huh? Well, but there are plenty of times when you'd want to do this to make yourself more adaptable. So I'm going to turn off the parametrics, and then all of a sudden you can start doing other crazy things. Like you don't even have to worry about how it got created. So actually if I go and I take these two edges, I can do things like take advantage of this move tool, and all of a sudden I can start moving things, or I can even start rotating them, or rotating whole faces. Like if we go and I build like just build a quick box here, you can see that it takes on really more of a way of modeling like SketchUp. So for those of you guys who have used that tool, that's what's called a direct modeling tool. So I can move this, I can move the face, I can move it out. Let's see if I want to move these two together. Actually, let's move this guy. Well, just think. So you can see, so now I'm actually moving the faces as opposed to worrying about modeling through a sketch. So with this push-pull, I'm able to start creating, you can create fillets, you can create your chamfers. This is all just done through a series of right clicks. Let's go with this guy. Yep, that's what I wanted. Yes. So you don't have to worry about, as this is a very simple example. I'm going to show you some stuff actually on the more complex UAV model, some of the stuff I can use with this kind of move tool. So parametric style modeling, which would be analogous to what you see in Pro E and SolidWorks. Move face, just dragging, pushing, pulling on edges, which is more analogous to maybe what you would see in like a Google SketchUp, if you're familiar with that tool. The third area that we have within Fusion is we have what's called a sculpting model. So where this gets interesting is if you want to talk about being able to create things like if we wanted to create the outer edge of like a fuselage, or sometimes for more organic things like what else would we use sculpting for in this example? Well, actually the fuselage is probably your best example here, but this is saying if we wanted to do if you want to just make it so that it, rather than modeling with actual geometric shapes, if you want to do things that are maybe a little bit more organic in shape. So where we see people commonly using this are for things like if you're going to model, like for instance, like a lamp, or if you wanted to model maybe like a so lamps, furniture, beautiful sculpted objects, artwork. This is what's called the sculpting environment. And so this is just another one. I'm not going to dig too far into this one because I realize that you guys are designing drones and probably won't use this as much. But if you guys are CAD enthusiasts and you love just modeling beautiful things like artwork, or I can show you some other examples of things we've done here. We've made some just amazing CAD models here, like beautiful guitars, beautiful chairs, I mean everything, with this other totally different, more flexible sculpting method within Fusion. I can talk your guys' ear off on this one, but realizing kind of our audience there, I'm gonna hold off on this one. But this is actually one of my favorite parts of Fusion. So let's dig into some of the examples here. Oh, actually, no, I'm not digging into examples yet. I was going to give it over to Chuck to talk about some honeycombing stuff. I guess it's probably... Chuck, are you in a spot to talk about that? Maybe, actually,
sure.
First, let me quick ask on fundamentals. That was the question here. What is the difference between... So before I give it to you, Chuck, let me finish my final thing. I'm trying to address what is the difference between this and other CAD tools. So give me another 2 minutes and I can bring this guy to a close. So I talked about the differences being that we have several different modeling styles within Fusion that you wouldn't get within SolidWorks or within SolidWorks Pro E or CATIA. The final thing of what you get within Fusion is you actually get a more adaptable and user-friendly way to be agnostic with the CAD you're using. So what I mean by that is that we can actually import, if I go and I upload different CAD types, my local hard drive here, you can actually see that of the different CAD types we can bring in, we're highly flexible with being really friendly to everybody. So sometimes, like in CATIA, they're pretty notorious for making you buy add-ins to go bring in different types of CAD. Out of the box within Fusion, we can bring in natively created CATIA parts, we can bring in natively created Pro Engineer parts, natively created SolidWorks parts, a whole set here. So we're really flexible in allowing you to do stuff with the CAD. And what's allowed us to do and with our team within the Team Oxpecker that I'm involved in is we have a couple guys that they had a couple of concepts that they built out in SolidWorks. So this is one that actually one of our teammates named Ryan created, and it's this really cool looking model. We're able to bring it into Fusion, and even though the rest of us, we don't have SolidWorks, we're able to go and then take and actually go and we can edit the geometry. We can go and play around with things. I'm able to go and change things like if we wanted to play around with different diameter sizes, different lengths, if we want to pull things out. If we want to make it so that things will fit within this space. A project that actually Princess Aliyah, Chuck, and I were working on right now with Asia Tech drones. We actually have a model that was created. I think it was SolidWorks, right? We were created. So I have a model. Actually, maybe we'll show that later. We're going to be using Fusion to take the SolidWorks model and fit in the lighting tool. Oh man, GoToMeeting got mad at me again. Okay, hold on, I'll be back. Sorry guys. I'll be right back. Fusion. So okay, so we'll be using that to to put in the camera system that we put in. We're going to be using it to put our strobe light in there. And the reason why is because Fusion is just so adaptable. We can do these cool cutaway systems that if we had to worry about maintaining file relationships within our parametric modeler, it would slow us down. I mean, so we can actually use the two in tandem very nicely. Okay, long-winded answer. So highly flexible and pulling in different CAD formats and then different modeling techniques. That's in short kind of what makes us both different and similar to the parametric modeling tools you're familiar with. How'd I do, guys? Is that clear? Let's see here. Questions? Let me ask the two. Chuck, what did you think? Was that?
It's interesting to me that, it's nice to see the different types of modeling, how you can mix them together. I know a question I had once you turned off the parametric is whether you could turn it back on and apply to those things you were pushing and pulling.
Sure. So questions about that. So if you guys get into it and you want to start building up equations, like do the parametric modeling, if you turn them off at this point, you can't turn them back on. So that's just one of those things. Kind of once you break it, you're done. So not at this time.
That's what
we've had. Yeah. It's one of those things. If you anticipate that you're wanting to, if you might want to go back, it's pretty common to just have a parametric model and then just insert it into a different model as without the parametrics. And then if you need to get a new one, you just go get another one and pull it back in and just manually update it. Yeah, it's one of those things like parametrics. It's like you want to be as efficient as you can with equations, but the moment you spend more time trying to keep everything associative, it's that balancing act. There's a lot of, you're trying to be a pragmatist in the CAD world. You want to do just enough to get yourself to the next thing while being proactive enough to make sure you aren't totally hosed the next time around. So there's that. Well, there's no secret sauce there.
Yeah, I always saw parametric. Its main benefit was for family of parts kind of thing, where you're doing
totally.
So it's not for a single pointed design kind of thing. It's more for families of parts, gears and things like that are based on equations.
Mm-hmm. Totally.
So, yeah.
So let's talk about the what are we calling it? Honeycombing. Let's give it over to you for a little bit, and then we can come back to do some more modeling stuff.
All right. Well, the honeycombing that, from the 3D printing world, of course, there's two ways to approach it. One is the honeycombing that we do after we receive a file. So I have I don't know if you can see this very well or not, but the helmet, and it's actually built hollow. And if I hold it right, you might be able to see some of the honeycomb inside of it. See if I can get it right in the light. But this is done with stereolithography, so that's the liquid polymer kind of style. You can kind of see some of the honeycomb in there. There you go, on the top there. So these models, these helmets were done for a company that wanted to do wind tunnel test models. So, of course, you don't want a solid piece of plastic sitting on the cyclist's head as he's in the wind tunnel. So, so we have one that's done in stereolithography, which is the liquid polymer, and then one in FDM, which is the extruded thermoplastic filament. So when we're building in the liquid polymer, of course, we need to have a way to drain all of the liquid out of the inside of the part once we get done. And so what we do is we build this in a honeycomb fashion. So when you're modeling it, you would send us this solid model, and then in our build process is where we put honeycomb in, and then we have to drain the liquid out if it's stereolithography. So what I want to show you a little bit in software is the FDM model, so that I can show you how it creates this hollow, because this is hollow as well. The two parts, I think, weigh within 0.5 gram of each other, but the FDM part, this black one here, is made out of ABS material, and of course the stereolithography part is made out of that epoxy acrylate material in stereolithography. So, so I probably just lost everybody, but let me show you some of the software.
That's
where
pretty
we.
Cool. Let me make you the presenter.
Okay.
Yeah, you're on.
Come on.
I guess I can ask. Yeah, if you guys, if you lost you, let me know, and we can go back.
So again, we can do some things since we make parts layer by layer. That's basically what's going on with 3D printing. What I'm going to bring up, this Insight software here, is actually what we use in order to prepare build files for running on FDM equipment from Stratasys. So that's what this software is. And so what I'm going to bring in is, I'm going to bring in a car throttle body. So that's the piece of geometry that connects the carburetor to the intake manifold. So let's see if I can find a file here. Looks like everything's going slow this morning. Right. So this is, what you might see from the output of your CAD system, this solid model of a throttle body. So it might look familiar to some of you car guys or motorcycle guys or maybe even aircraft. But normally what we would do with this is that stereolithography part I showed you earlier, we make a lot of those hollow like that as casting patterns. So we send them off to a foundry that uses that pattern instead of a wax pattern in the lost wax casting method to turn into an aluminum part. So what I'm going to do here is I'm going to pull up I'm going to slice this file basically and show you some of the slices so you get an idea of how we make that hollow inside. Oops, didn't want to save. So I've got some styles here, and I should be able to slice this up pretty quickly. So this is going to be kind of boring while the software is working, but when we get done, what we're going to have here is we're going to have a good demonstration of how the process works in FDM. First of all, showing the slices. We'll take a look at some of those slice by slice. Also, you'll get to see how the part needs to be supported. So it'll create support structures. That's what it's doing right now. So
Chuck,
really,
for Insight, is this a program that they're downloading and they're doing themselves, or is this something that you guys help with?
This is something that you tell us you want it hollow,
okay,
and this is the software that we would use to make it hollow.
Okay, so like with Brad, with our team, if we came up with a CAD model to you and just said, hey, we were thinking honeycombing technique, what do you think? This would be what you guys are doing on your end.
Right.
Yeah.
So this is all stuff we do on our end.
Okay.
Now, when you design a part, I can't get my screen to minimize now, but when you design a part, you can design any kind of structure that you want in there. Now you have to know the process that you're going to print it in, so that you know what you have to do in order to get that design to turn out the way you intend it in the part that we build and deliver to you. Mm-hmm. So FDM, since it builds in air basically inside the machine, whatever structure you design in there, the only limitation we have to building that structure is support structures that are required in order to support that as it's being built. So for instance, we have a wing that we built, and it had some CAD design structure inside of it to make it hollow. And the structure inside, so if you looked at building the wing structure up in this way from root to tip in the vertical direction, there was structure that was designed in at 45-degree angles to provide stiffness to that wing, and we could build that without supporting it. So the wing could be hollow then in FDM and have that basically truss structure in it, and to make it rigid and make it so that it wouldn't flex and twist and things like that. But if the angle had been less than 45 degrees by much, if it had been shallower, there would have had to been support structure inside of that. So now the support would be inside of the wing. There's no real way to remove that. And so you would get a design or a part from us that wasn't the way that you designed it. So we might build that in, say, SLS, which is a powdered plastic process. And as long as we had a hole in one end of the wing, we could get that powder out of there and be able to deliver that part as you designed it in CAD. Now, most often, we like you just to send us the design, and then we use the software, like I was showing you there, to create the part hollow itself. So it's still working here. This is always the longest part of the process, creating supports for the part. So I wasn't intending to show this, so this is a this is off the scripted part of the program, I guess. So anyway, I don't know if I was clear there on the differences between what we can do, what you can do. The bottom line is, if you engage our project engineers as you're designing and thinking about how you want parts built, our project engineers can lead you through the different processes, materials, how it might affect your design, those kind of things. Also on our website, we have things like design guidelines. So let's see if I can show you that real quick. Hopefully this doesn't exit the program. But we have, under resources here, we have design guidelines, and these design guidelines are for different processes. So for the 3D printing, SLS, FDM, those are the processes that we use most for UAVs. And then we also have a 3D printed metal that you might want to use for some parts of your engine design, mounts, exhaust manifolds, and mufflers kind of thing. So I don't know if any of you are thinking about the noise that UAVs create and things like that, but we've had people create mufflers for their gas engine designs if they're using those on their UAVs. And then that way they can minimize the sound from the engine of the UAVs. So those things are available there. See what's happening here? It's speeding up here. So what it's doing now is it's creating the outside boundary curves of the part. So again, we're extruding the plastic layer by layer, so it has the boundary curves that define the outside of your part. And then what I really want to show you on this for the hollow parts is the hatching pattern that goes on inside of the part and creates that hollow structure that you get on the inside of the part. So in a few minutes here it should be done. Let's see, I wonder if we have see if I can find some pictures of our quick cast patterns here. There we go, investment casting patterns. This might give you a better idea of how parts are created hollow. So here's a picture of that honeycomb structure that you see inside. Now this again is a stereolithography model, and so again, when you're building in a vat of liquid, the pattern comes out, it's full of liquid inside. So we bought some centrifuges that were intended for the honey market, the people who keep bees, and they're used to spin honey out of the bee's honeycomb to get the honey out. Well, we use the same kind of centrifuges to spin the liquid stereolithography resin out of these patterns. And then the patterns, of course, are used to create metal castings. Getting near the end here. Am I doing a good job at stalling?
Well, what I see the value, of course, why you're doing that. I mean, like honeycomb effect. I mean, because it reduces weight, right? It reduces costs and materials, the space.
Right.
I mean, and it doesn't really. I mean, if you're using the right one, it doesn't compromise rigidity or strength. I mean, these are the sort of optimization things that, regardless of how long the actual computation time takes, is highly advantageous. Right. Where strength to weight ratio is critical. So I'd say with any part you guys are considering doing, I mean, I think there's a couple engineers on here that I think I'm preaching the choir, but for those of you that aren't really familiar with, what's the benefit of what he's doing here, it's just that it's going to make your parts lighter and every bit as strong. It's a good idea to go and do this if you aren't. Right. Now, the examples I've been showing you, like the throttle body that's slicing and that other part that I showed you on the web there, you need walls of a certain thickness in order to benefit from building them hollow. So you may have a fuselage, and those are the things that we normally build hollow, fuselage and wings. But you may have a fuselage, and then you have
the envelope in there where different pieces of hardware go, either camera hardware or control hardware for servos and things like that. If you design those pockets inside of the fuselage and the rest of it is solid, then that's a good candidate for sending to us and having us built in a honeycomb kind of fashion so that we can reduce the weight on that. The FDM process, why I wanted to show you this was that we do have some variability into how thick we can create the skins on the fuselage. So we can talk that over with you, and you can try out different skin thicknesses. Of course, you might want to try the extreme minimum skin thickness, but of course that's going to give you the lightest weight possible. But it may not provide enough structural strength in order for it to perform its function.
So Chuck, when you're evaluating those kind of minimum thicknesses and such, do you do your own strength calculations internally? Or I guess my question, and there's a question that came in actually from Ron, asking like, could we take what you did there, put it back into another FEA program? Like I'm thinking specifically like with Fusion, we can use a program called Sim 360 to do structural analysis. Is that the type of thing you guys do?
We do not do structural analysis. Okay. We're a manufacturing company, and so the engineering is up to our customers.
Okay.
So we try to provide all the information though about the manufacturing process. So for instance, in the FDM process, it kind of the minimum thickness there that we go to is 60 thousandths of an inch skin thickness. So that's about 1.5 millimeters. Skin thickness is about the smallest that we go. We could go smaller, but then you run into other problems with layer adhesion and things like that could make the model weaker than intended. So those are all the kind of things that are in the design guideline. We talk about minimum feature size and thicknesses and things like that. And so we have some of those recommended minimums that are based on, they're kind of constraints of the manufacturing process or 3D printing process itself. So, but again, that's why we have that staff of almost 40 project engineers, so that they can talk to you more intelligently about it and understand your application, what you're trying to do.
Okay. So once you get this file format, that's in an STL format. Is that can you get it out as like a step?
Well, if we received a step file, we would have to convert it to an STL file in order to send it to the 3D printer.
Okay. If we wanted to take this model and go back to CAD, can we do that?
The throttle body?
No, the one with your honeycomb effect, with the actual honeycomb.
The one I'm slicing.
Yeah, the one you're slicing up right now. Yeah. Could we get that back into CAD?
Well, I think all I have is an STL file.
Okay. I could get it back in. If there's, I wonder, it might be interesting if you sent me that file. The question that kind of towards some of these guys are asking, like, hey, could we actually do some structural testing on this? And actually, there's a way.
Sure.
Fusion actually has a finite element analysis tool. So I'm geeking out with the mechanical engineers here. Bear with me. But
no, that's fine.
It would be interesting, like if we're working with you guys and to get this print, this idealized weight. It might be an interesting kind of workflow for some of these guys that have teams. I know that there's a lot of academics in this competition. That might be an interesting back and forth because they might not have access to your honeycomb tool. But,
right.
They could actually make sure they're making, safer, sounder, more, articulate decisions if we had if we figured out what that workflow was. So Ron and crew have been asking me. I'll work out with Chuck on this stuff and kind of see if we can do it. We do actually have a tool within Fusion called Sim 360, which allows you to it's in the same interface there. You can actually basically send a simulation and you can do some structural analysis along with modular analysis. There's a couple other different simulation type tools within that. So actually, if there's interest there, we could do a specific session on that if you guys are interested. But I'll work with Chuck.
Okay.
Thanks,
I just emailed you the STL file for this particular file.
Cool.
So what we're looking at here is the layers of the part. So if I show you all the layers, what you'll see in red are the boundary of the throttle body itself, and then all these gray kind of supports in the cream color, those are the support structures that are required. So you can see that anywhere there's a feature on there that is cantilevered or hanging out over, because you have to start building on a that platform or that bottom plane, and then you build up from there. So as you get up to these cantilevered features, these bosses that stick out from the side, course, it requires a support structure in order to have something to build upon once you get up to that layer. So if we go back to looking at the layer itself, and so what you're seeing here is the actual tool path of that the extrusion head's going to follow as it creates this part. And so again, the way this was set up is this is set up to have a couple of different or a couple of passes on the outside of model material in order to build this part. So the blue is the support structure, and then the green is the actual part itself. So let's see if I can figure out how to zoom out here. So if you look at the green, the first few layers of the part are solid, of course, on the bottom, and that's so that this part is completely sealed. I don't know what that was.
This just really wants to change the color.
But as I step up through, yeah, so now that you can see that we've gone through that bottom of the part, and so those solid layers are now gone. So, this is the last solid layer on the bottom, and then I go up, and now it starts creating a hollow structure inside. So all of this blank area, this black area, is air now inside of the part. So you can see out here it's got 2 passes with filament. These are 30 thousandths wide. We do have some control over how thick those passes are. And then inside there's this big air gap that I can define as well. So if you watch as I step through the layers, you'll notice that the direction of this hatch structure here, oops, let me zoom out a little bit so we can see it a little bit better. As I step up through the layers, you'll see that the orthogonal direction of the hatch will change. So layer by layer, it just goes from a 45 to a 135 kind of direction to create that hollow pattern. And so it provides enough structure so the outside of the part will hold its shape, but also puts as much air inside of that part as possible to make it lightweight. So that's kind of, it's real simple when you look at it. 3D printing is always really simple. It's a 2D process that you repeat over and over and over again. So, of course, that's until you get into the materials you're processing and the shrink factors and how that might deform your part and how you need to orient the part as you're building it, and all those other kind of things that we're expert at, and that's why you come to us. Brilliant. So I don't know if that's kind of gets the idea across of what we can do from a 3D printing side.
Cool. That's awesome.
Yep.
Okay, let's see. Do you guys have any? I guess there's a couple people kind of saying they were looking to drop off kind of the end of the hour here. So like Jay, for instance. Jay, thanks for dropping in, man. We will we'll publish the rest of this online. Yeah, so we'll see you in a bit. So for those of you guys that want to stick around, I know I thought we'll probably try and come to a formal close at the end of the hour, and then if you guys want to stick around longer, I can. I don't know if Chuck and Princess Aliyah, I don't know if you guys got to drop at the hour.
I think I allotted an hour and a half, so
okay.
I got another half.
Okay. Yeah, well, we'll publish whatever we end up here. So kind of the next spot, so what we've covered so far is kind of some of the differences between kind of what Fusion does to both complement it and how it's different from existing CAD. Talk a little bit how Chuck can help work with you guys to help create, to minimize the material used for when you guys submit to get those 3D models 3D printed. And then I was going to kind of close this final part and just showing some of the more advanced kind of ways that we've seen Fusion be successful in drone modeling, and then dialogue with you there. So if you guys are cool with that, we'll keep going. Yeah, and Princess Leia, can you see the questions that are coming in as well on the chat?
Yes, I can. Sorry, I had you on mute.
No problem. If you wanted to look, Michael's got a question for you there. Asking if you want to just look at that guy. I think that's a question better for you. So yeah, take a look at that guy. I know take a look. So,
Mike, you can actually, or Michael, you can actually get up to $1,500 of 3D printed from Solid Concept. So once you know how much it would cost you to get your particular design printed, and Chuck went over the rapid prototyping and getting a rapid quote. So with that quote, submit that quote to us and just what it is that you're designing, and then you can get a grant up to $1,500. But you know what? If you need a little bit more, we could definitely work that out. So that should not be a problem.
Scroll up and look at his question's a little different than that. So yeah, take a look at
Oops,
his
sorry.
take a look at his question and just you probably can just chat on the
Okay.
side there. Yeah, take a look at his question. But yeah, that's the quick
See
answer
it?
for everyone else. Yeah. So guys, everyone
Oh,
else, we're covering what else could you do? I mean, seriously, what could we 3D print and what are the advanced examples to kind of help build some vision around modeling? The first thing of kind of what can you bring in the more advanced models? The first one is definitely remember in your spaces kind of where you can go to bring in other existing CAD. I mean, don't shy away. If you already have a perfectly good CAD model, don't shy away from it. So first tip for you is remember in the upload section here of your project space, remember to upload your CAD space so we can bring in stuff. I mean, quite literally that fuselage I'm showing from, that was created in a different program. Let's show some examples, some actual CAD modeling examples to play around with. So let me show you a quick video I've got pulled up here. I showed an example in our first webinar of showing how to make a 3D printed printable gas tank. So I'll show you where that example is. Let me show you one of the other ones that we've done as well. Here is I apologize for the frame rate of this, but can you guys at least see the video? Chuck, can you see my screen? Okay, I'm going to show you.
Yeah, it's stepping through.
I'm going to show you an example of taking a wingspan, and then this is just the quick kind of 15-second version. I'll let it loop a couple times. This is an example of being able to use, not having to worry about dealing with parameters or constraints. You can actually, first off, shell your wing from the space. So whether you choose to use, in this case, these are kind of long spars. A lot of people go actually the short way, which makes a lot more sense. But hey, I was making the video quickly. This is a good example of doing what's called an advanced process. This is called Boolean modeling, and saying you're taking the positive and negative space of the workflow. So this is another derivation of how we can use that in modeling. So what we've seen here is you shell it, you create your model, and then you actually use the wing itself to cut the shapes, and then you have these dissimilar sizes. So actually, if we turn off the visibility here, you can see that this guy, you now have 1, 2, 3, 4 custom sized spars to fit within custom spaces. So this is long. You wouldn't do this actually. In fact, you'd actually want them to go this way, hamburger as opposed to hot dog. If you're familiar with the American, I guess that'd be a metaphor. But you can have it so it's the exact precise size using this cutaway tool. So an advanced tool, I'll show you kind of what that combine does. The other example would be creating that gas tank. That's another great example of using the combine. So that's one of those advanced things that I think is really powerful. That's been very useful for us in creating usable geometry out of Fusion. So I can just show you some basics of how to get started doing that. So that was the kind of the payoff. What can we do that's, oh my God, that's so cool. The longer version of that actually is on, let me point you to a link on YouTube if you want to see kind of how I created that. Before I was involved with the Wildlife Conservation Challenge, I actually had I had a competition actually here locally in the Pacific Northwest that was called the Fusion 360 UAV Challenge, where we wanted to see if one of our users who was looking to get into creating basic kits for creating these really awesome UAV drones, if whether people actually had if they would be excited to actually create them. And so we actually made, for this guy, Stan Heisel, we actually made a series of videos for him to show how to model that. And so what I'm going to show you guys now is kind of some of these videos we had to kind of give you some ideas of what else you could model. So actually, if we go to the playlist part of this thing, in this Fusion UAV Challenge, if you look at the bottom, this number 12, this remove material and add stiffeners to your airfoil, and I'll paste this link by the way too. I actually give you, actually, if you can hear me,
that you might want to take
I will talk your ear off and show you click by click how to do that workflow. So let me post that one. If you guys are looking for something more advanced to do, that's your click by click. Let me post this in the chat so everyone can see it. So take a look in your chat thing. So this is kind of a fun one to follow. That'll be a good one. And then the other one I wanted to share with you guys of that, if you hadn't seen it, because I think there are a couple people that are new, is in our, actually I think for, it's here for our webinars. the previous webinar that we did, that Chuck and I did, all right, with Princess Aliyah, we did this one of how to create a gas tank. Videos. So if we go to this guy, I'll show you how to basically cut this guy apart, and from within it create a custom sized gas tank. And we were saying the reason why we showed this use case is Chuck has actually done this. I mean, they in professional grade UAVs, they get spaces at a premium, and so creating a custom sized gas tank can be one of those things that you have to kind of fit it within the fuselage space you have. This is a workflow that actually Fusion is absolutely set up to do this. I mean, if you guys just take what you did in SolidWorks, but if you guys are going to try and make things custom fitting, so whether it be a gas tank or for electronics or for like what we're doing right now with our task, trying to make a camera fit, take a look at this workflow in here. I started around like 36 minutes. Take a look at this guy if you didn't see the first one, or if you guys are like, oh yeah, I totally remember that, let's try that. Go back here. We go through the clicks of that, so that's a good one to kind of get familiar with. So here, I'll go throw that guy down as well for you. And then let me look back at the questions. Are there any specific use cases you guys were looking at? If you have them, throw them my way, because I'd be curious. Because if I can, I might be able to even share with you those workflows, because we've modeled it. I mean, that model that you're looking there on the screen there, Stan, myself, Brad, right? We've all done a fair amount of modeling with Fusion for this specific challenge. So I think we've got a pretty credible group of people that if you guys are looking for a particular click track, I think we can help you guys all be successful here. Just let me know what you guys need. Yeah, it's pretty rare that you have like a mixture of CAD people excited to help you model it, and then you have with Solid Concept, have an actual fabrication facility excited to make your parts for you. I mean, this has been a new one for me, and I'm pretty excited. So I mean, wherever we can help you guys be successful here, let's make it happen. This is a cool opportunity. Okay, questions are on there. Let's see here if I pull this guy down. Okay, questions. Elmer's up and running. Awesome. Okay, so not a lot of questions coming in here at this point. So maybe we'll leave it those two use cases there. If you guys have questions, I've been in touch with some of you guys kind of offline, but if you have questions, remember, get in touch with us. So Chuck, Alexander, and I, we're available on the email. Here, I'll post down here. So here's my email. And Chuck, I guess I didn't ask, but I'm going to post your email anyway.
That's great.
If I can remember what it was. It's Chuck. It's just Chuck Alexander at Solid Concepts, right?
Chuck.Alexander
at DAR at solidconcepts.com, right?
Correct.
Yeah. Alexander. Is it AR or ER? AR. ER. Yeah, ER. All right. Correct me if I'm wrong on this, but yeah, there's that guy.
Mike, can we have our South African director, LB Williams, kind of say a few things about the progress of where we are in South Africa?
Absolutely, absolutely. Yeah, here, I will I'll promote him. Yeah, we can get that. It's Scott, right? I'm promoting Scott.
Yeah.
Yeah.
Scott Williams. Sorry. Yeah. It's weird. I don't know. Sometimes I call him Scott. Other times I call him LB. So if I say Scott or LB, it means our South African Wildlife Conservation UAV director. So.
I don't know if I can promote him. I can unmute
Can you
him. Let's see if I can. No, why am I not able to promote him? This is interesting. I can unmute him. Scott, you are unmuted. Hello.
Yeah, excellent.
How you doing?
LB is probably better. I won't answer you if you call me Scott. So.
Why are you logged in as Scott?
Quickly, a couple updates from this side. Just some things to make it hit home. If you haven't seen the faceless rhino pictures and video from Kruger this past week, go ahead and Google faceless rhino in Kruger. It's an unfortunate event, but I was able to speak to the people who actually took that photo. They were staying with us 2 days ago down here in the Eastern Cape. It took almost a week to find this rhino,
Oh,
which
man.
had been mutilated, and they had to euthanize it. But it's an interesting story of explaining exactly why we're doing what we're doing, because they couldn't find that rhino, which literally, as you'll see, was missing half of its face. So it kind of puts into perspective what's going on, and I know that's a sad story to say, but the exciting part is that all the teamwork that we get to sit here and watch you guys do on these webinars is exciting for us in the field who get to see, guys getting a chance to work with the experts, and we're very excited about that. So that's the one thing. If you haven't seen it, take a look at it, and I don't usually get into the gory details, but it will put things in perspective. From the front on this side, we continue to coordinate with the CAA to make sure they're happy with the UAV challenge as it stands. We'll be putting the finals in a private reserve, so they're getting all of the authorizations in place so we can essentially fly legally. We'll meet their parameters, and that should go well. And a few updates from that final site. We just surveyed a 580-meter runway. So
Nice.
we'll be flying our gyro in and out of there before month's end, and shooting some imagery from the finals location just so people can see that. And then,
Nice.
as Aliyah alluded to, my team will be working with Sand Parks to get into Kruger and get footage from the Kruger Park so everyone knows what that looks like as well. So exciting stuff on this end.
Yeah, we're thrilled to have you on the ground, Albie. Thank you so much for all your hard work. And the fact-finding mission 2 is going to be a challenge, but I know that you are the one that can make it happen. So we've got our trust in you to make this one happen.
Well, thanks, Aliyah. It's been a pretty busy couple weeks, and we'll be out at another small reserve in the Eastern Cape tomorrow, meeting a brand new appointed anti-poaching head of anti-poaching for one of the local reserves. So it's exciting to see the smaller reserves are starting to get enough support that they're able to hire the teams, and now they just continue to call for tools. So a lot of infrared camera requests, and thanks to some of the sponsors in the UAV challenge, we're getting some great discounts. I think we got 40% discounts on infrared cameras today for handheld personal equipment. So the UAV challenge is actually getting a lot of other things. The side benefits is the sponsors that are sponsoring the challenge are also helping the guys here in the field with discounts. So we're highly appreciative of that.
Yeah, and I do want to say that my communication with FLIR is progressing very well. So we are working on those cameras for the teams. But
Nice.
FLIR is also donating some cameras to us for our fact-finding mission, for our research collection of data and stuff, both for the UAVs as well as handheld. So Albie, you'll be getting some stuff for the Rangers to be able to use and give us feedback on as well.
Yeah, that's excellent. And like I said, even the small budgets that we do have, they did some really good work for us today on pricing as well. So thanks very much to FLIR. Since you said their name, I'll go ahead and say it too. We're very appreciative of all the help.
Cool. All right. Well, does anyone have any questions about any of the upcoming events that are coming up?
Yeah, we'll just get them posted.
Okay, sounds good. Well,
That's on
I'll
us.
see the teams. Yeah, I'll see the
Yeah.
teams on Sunday. Hopefully, I'm looking forward to our first web meeting with the teams.
Yeah, I'm looking forward to it too.
Yeah.
Well, good stuff. I guess we'll pull this guy to we'll land this bird, and we'll see you guys next time. Thanks for joining in, guys. We'll yeah, for those who've been chatting with us, we'll be following up with you and stuff, and it's been fun. So yeah, on behalf of Chuck, Princess Aliyah, and myself, you guys have a fantastic afternoon, meeting, morning, wherever you are.
All right.
All right.
Thank you.
Take care, guys. Bye.
Bye.